just wanna see the light.
Hey guys, today we'll be continuing my textbook reading. Yes, it's already episode 3, very fast. So today we are going to read chapter 1.2. What is the nature of scientific knowledge? So let's begin. In science, evidence plays an important role in supporting theories and hypotheses. Evidence can be obtained by observing natural phenomena or conducting experiments. For example, by studying the physical traits of a fruit, we may conclude that it is a coconut. Which senses are needed to identify the coconut? As you can see right here, figure 1.8. We use our senses, sight, hearing, touch, smell, and taste to make observations. These observations that describe the objects or phenomena are called qualitative data. They are usually expressed in words or drawings. Qualitative data is useful in helping us to visualize an unknown object or learn about its characteristics. We can also use our senses to estimate the weight and volume of the coconut. However, to obtain the actual weight and volume of the coconut, we need to use specific instruments. Measurements are numerical quantities of an object or phenomenon called quantitative data. Figures 1.9 to 1.11 shows some examples of quantitative data. 1.9, 1.10, 1.11. Table 1.2 compares the characteristics of qualitative and quantitative data that we collect as scientific data. When designing scientific investigations, we need to consider the types of data to be collected and the ways to collect it. The data may be qualitative or quantitative or even both. Construction of scientific knowledge. As science is evidence-based, data has to be collected, usually through observation. The data is analyzed for patterns or trends, which are then used to make inferences and conclusions. These inferences and conclusions may support or reject a scientific idea. Inferences are also used in history, if you guys don't know. Continuing. Throughout history, Earth's position in the solar system has always captured significant interest. For thousands of years, astronomers believed that Earth was the center of the universe. Okay, here's the book is in dark mode now. That's good. I don't know how to read the name, seriously. A European astronomer and mathematician introduced the idea that the sun is at the center of the solar system. His idea was based on his analysis to data collected over many years. While he gained support from a few scientists, he was unable to convince most of the scientific community. His experience shows that the scientific community may take time to accept the idea. This is partly because scientific evidence is interpreted based on a set of strongly held assumptions. However, in light of new evidence, alternative explanations may be proposed. Hence, scientific knowledge is subject to change. This paves the way for further discoveries by other scientists later on. Well, I don't know how to read them also. An Italian astronomer, physicist, and engineer improved and built a telescope to observe distant objects. He was able to observe the moment and even the surfaces of some planets. This provided observable evidence to support the idea that the Sun is at the center of the solar system, and that Earth and all the other planets revolve around the Sun. Advancements in technology can help to shed light on new evidence that supports different conclusions or viewpoints. When more evidence is accumulated, assumptions will start to change. Over time, new understanding is formed. This example demonstrates the shift in understanding of Earth's position in the solar system. It illustrates how in science there can be multiple interpretations of the same phenomena. Despite observing the same planetary system, the three scientists collected different data, which led them to make different inferences about Earth's position in the solar system. Since scientific evidence can be interpreted in many ways, how do we know which interpretation should be accepted? The scientific community has to consider and analyze evidence thoroughly before accepting an interpretation. This shows the crucial role that the scientific community plays in building scientific knowledge. Okay, that took me 6 minutes though. This is the longest episode of Learning Science I see. But anyways, tomorrow we'll be reading chapter 1.3, How Do We Practice Science? And it goes up till it's quite long. It goes up to on page 12 to 24. That means 13 pages. So I might be doing a 1.3a and 1.3b, and they will premiere on the same day. So yeah, so I would read 1, 2, 3, 4, 5, 6, 7, and then what in 1.3a is up to 18, and 1, 2, 3, 4, 5 up till here. So yeah, hopefully you guys enjoyed the video, and see you in the next video, the next episode, and bye bye.
I just wanna see the light.